Hello friends, today's question. A resonance tube is old and has a jagged end. It is still used in a laboratory to determine velocity of sound in air. A tuning fork of frequency 512 Hz produces first resonance when the tube is filled with the water to a mark of 11 cm below a reference mark near the open end of the tube. The experiment is repeated with another tuning fork of frequency 256 Hz, which produces first resonance when the water mark reaches a mark of 27 cm below the reference mark. The velocity of the sound in the air and obtained the experiment is close to. In this case, we are supposed to find out what will be the velocity of sound in air. And the important term here in the question, it is mentioned that the end is jagged one. So it means because of this, a term associated with a end correction will be introduced in it. And because of that, there will be slight change in the calculation. So let us start from the information that is given to us. We are given that the frequency of first tuning force, let us suppose it is F1, is given as 512 Hz. Frequency of first tuning fork, let us suppose that is F1, is given as 512 Hz, and the length of air column is given as centimeter. We convert that into meters. So we say length of air column, let us suppose that is given as L1, and which we can write as 0.11 meters. Same information we can write for second tuning fork. You can say frequency of second tuning fork let us suppose that is given as F2, and this F2 will be equal to 256 Hz, and the length of air column is in this case is 0.27 meters. Length of air column, let us suppose that is L2, and it will be given as 0.27 meters. Now the term that is mentioned in the question is that the tube has a jagged end. So we say tube has a jagged end. So therefore, the correction factor due to end effect will be introduced. The correction factor due to end correction and that correction factor is our end correction, and we call that as E. So therefore, the length will be now called as a length effective. So we can say our L effective will be equal to L plus E. Okay. And where this E is our end correction. So let us call this as question number 1. And we have for the first resonance, for first resonance, we can write that our L effective will be equal to lambda by 4, where lambda is the wavelength of the sound. Wavelength of sound. And if v is the velocity of the sound, so we can write that our velocity of sound, if it is given as v, then v will be equal to frequency multiplied by lambda. Now we have two frequencies, so we are going to use equation 1 for both length of the tubes, L1 as well as L2. So let us call this effective length for each tuning fork. Effective length for each tuning fork. And using equation 1, for first tuning fork, let us call that length as length effective 1 will be equal to 0.11 plus E. And for second tuning fork, if length, we call that length effective 2 will be equal to 0.27 plus E. And the wavelength that is given as lambda that is our lambda will be equal to 4 multiplied by length effective. So we are also going to modify this equation for both tuning fork. So we say for first, we have lambda 1 is equal to 4 times length effective 1, which we already know is our 0.11 plus E. And for second, we have lambda 2, which is 4 times L effective 2, and that is 4 times 0.27 plus E. And the velocity of the sound will be same for both the cases. Velocity of sound will be same for both tuning fork. Therefore, we can write that V will be equal to F1 multiplied by lambda 1 will be equal to F2 multiplied by lambda 2. We substitute both values, F1 and lambda 1, F2 and lambda 2. F1 is given as 512 multiplied by 4. Lambda 1 we just found out is 0.1 plus E. F2 is 256 multiplied by 4, and this is 0.27 plus E. And our 4 and 4 cancels out. So we get, if you open the bracket, we get this as 56.32 plus 512 times E is equal to 69.2 12 plus 256 times E. Now it's a matter of simple calculation, and from here we can write that our E will be equal to 12.8 divided by 256, and which comes as 0.05 meters. So we were able to find out the end correction, that is value of E, and based on this value of E we are going to find out the effective length. So next is our calculation of the velocity of the sound, which is our final part to solve. Calculating velocity of sound. So let us first find out our L effective. L effective 1 will be equal to 0.11 plus E, and that becomes 0.11 plus 0.05, and this comes as 0.16 meters. And we can find out here lambda 1, which is 4 times L effective 1. So this is 4 into 0.16, and this comes as 0.64 meters. So velocity V will be equal to F1 multiplied by lambda 1. F1 is our 512. Lambda 1 we just calculated is our 0.64 meters. So this comes as close to 328 meters per second. So this is the velocity of the sound. And the options that are given to us, we can say option number A is the correct option. Option A is correct. A is correct. So this completes the question. Thank you.